gentlemen, I just want to give you guys a visual in terms of the factors that affect solubility, okay? Now, on this hot plate right here, got some water and it's boiling. To show you that it's actually boiling. Can you hear that? Bam. Okay, so it's boiling right there. Now, temperature, right, is one of the universal factors, right, that we have in chemistry. It affects a lot of different things, okay? So, depending on the temperature, you can get a reaction or process not taking place. And in terms of solubility as a process, right, it's sometimes if the temperature is cold enough, like if you put the process or the substance in cold water, like ice water, it won't take place, okay? So temperature is one of the important factors in terms of solubility. All right, guys? No problem. Okay, now we did also indicate, right, in the introductory video that we're gonna imagine this is a soda can, right? And we said that if you drank half of it and it's opened, you will not put it, right, on a hot plate to preserve the carbonation. You'll put it in more of a colder environment, right? So once again, if you put this on the hot plate, what's gonna happen is the gases inside, right, will get more and more kinetic energy. They will escape, okay? And the solubility for the gas will do what? It will go down, okay? So for gases, right, okay, we want the temperature to be cold, all right, doing cool, low temperature. Okay, so remember that memory device that we had? Low T and high P, right? Low temperature and high pressure. Okay, so that's for gases, all right, no problem. But just think of a soda can anytime you're dealing with solubility for gas. Okay, no problem. All right, so now the other factor we talked about, okay, was pressure. Now we agreed, right, pressure doesn't work, okay, for, let's say we have a liquid solute, okay, or a solid solid, right? Pressure doesn't work for those guys. But for if you have a gas solute, right, for example, in our imaginary soda can, right, we want to do what? We want to increase the pressure. So once again, temperature is a factor, all right, that normally definitely affects solubility. But for gases, it sort of kind of has the opposite effect in terms of temperature, all right? So we want to make a note of that. And pressure only affects what? Only affects gas solids. Now, the other guy that we talked about, right, was the fact that we have like dissolves like in terms of solubility. And that refers to the nature of the solvent. All right, so here we go. Now, I know you teachers probably done this in class a number of times. You got some type of oil. Now, guys, oils, fats, and waxes, right, they tend to be non-polar, okay? And we have water here, guys, all right? So classically, we know if we take some of the oil, I'm gonna open this guy right here, and pour it in the water, all right? Bam, okay? You see that? Okay? You're gonna have them not mixing well together, okay? See the oil up here in one layer, okay, and the water's there, okay, so they're nice and immiscible, right? So they don't mix. Reason being, we know from experience, right, guys, that water is a polar substance, okay? It's one of the major things that we need to know. Water's polar, it's an asymmetrical molecule, bend-shaped asymmetrical, right? Now, if you can't remember the SNAP rule and how do you figure out water's polar or non-polar, I'll post a video in the description when I go over molecular polarity, no problem. But, okay, this is an example right here of the concept that like dissolving like doesn't work because one guy is polar, water, and the other guy is non-polar. You want both parties, both substances, the solute and the solvent, to be the same, either both polar or both non-polar, for them to dissolve well together. So polar and non-polar, they don't mix. Okay, no problem. So next example, we got our water again, no problem, handy dandy water. But this time we're gonna put some alcohol inside. Now we have this old bottle of alcohol right here, ethanol. All right, this is the guy that people drink and crash into trees and stuff. It also has good purposes. It can be used to drive cars and whatnot, in the combustion reactions as a fuel, right? But we're still working on that. So we will place some of this guy, this ethanol, into the water, right? Okay, and I'll give it a little stir. Okay, now we're gonna notice a difference, right? See that? It's basically you can't really see any distinction in terms of where the ethanol is versus where the water is, right? They mix nicely together. Reason being, the ethanol is polar, okay? The water is also polar, like dissolves like, okay? No problem. So once again, you have to know the polarities of your materials in terms of whether you can figure out like dissolves like. You have to also know whether a substance is ionic or whether a substance is covalent. All right, now speaking of ionic substances, we have some table salt right here, kosher salt, bam, okay. We got some water right here, guys, alrighty, as we're winding down, okay. Now, the good thing is with water, right, it's polar, but it can also dissolve ionic substances or salts well, okay. You put some in there, okay, a few pieces. I'm going to stir it up. And we can eventually dissolve this, guys. All right? Bam. Okay. And you see over here, it's nice and dissolved, right? Now, this process, right, it's called hydration. It's also called molecule ion attraction, right? Now, I know you've done this in class or may not have done this in class, but the thing is, you have to look at the shape of the water molecule, all right? And it has different partial charges. For the oxygen is negative, and the partial charge for hydrogen is positive, okay? And it surrounds the different ions, the positive and negative ions of the salt, right, in a specific arrangement, and pulls the crystal lattice apart, okay? So that's something that you should also look up. But definitely, as we wind down, know that water is polar, bends, and asymmetrical, all right? And the like dissolves like rule, okay? If you have two guys like alcohol and water, they will dissolve nicely together. They're both nonpolar, okay? If you have something that's polar versus something that's nonpolar, they will not dissolve together. And let's say you had two substances which were nonpolar, they would also mix together nicely. All right, guys, as always, hard work and sacrifice equals success with a brief visualization of the concept of the factors that affect solubility. But please make sure you understand that you can figure out whether a molecule is polar or nonpolar. All right, take care.